Grounding screw used to attach grounding conductors directly to an enclosure without the use of a grounding bus bar is described as a grounding screw for direct attachment of grounding conductors to the enclosure. This type of grounding method is permitted under specific conditions outlined in the National Electrical Code, specifically Section 250.48. The purpose of a grounding screw is to provide a reliable, low impedance path for fault current to return to the source. This ensures that in the event of a fault, such as a short circuit, the overcurrent protective device, such as a circuit breaker or fuse, will operate quickly to clear the fault, minimizing the risk of electrical shock or fire. In a typical electrical installation, grounding conductors are connected to a grounding bus bar within an electrical panel or enclosure. The grounding bus bar is a conductive bar that serves as a common point for all grounding conductors. This ensures that all grounded components within the enclosure are effectively connected to the grounding system. However, 250.48 of the National Electrical Code permits an alternative method where grounding conductors can be directly attached to the enclosure without the use of a grounding bus bar. This method is typically used in smaller enclosures or in situations where space is limited. When using a grounding screw for direct attachment, it is essential to ensure that the screw is specifically listed for this purpose. Listed means the screw has been tested and certified by a recognized testing laboratory such as Underwriters Laboratories or Intertek to meet the requirements of the applicable standards. The grounding screw must be made of a conductive material such as steel or brass and must be designed to provide a secure and reliable connection to the enclosure. The enclosure itself must also be properly grounded. Typically, the enclosure is grounded by connecting it to the building's grounding electrode system, which consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding electrode conductor that connects the electrode to the main grounding bus bar in the electrical service panel. When installing a grounding screw for direct attachment, it is important to follow the manufacturer's instructions and the requirements of the National Electrical Code. The grounding conductor must be properly sized according to the size of the circuit conductors and must be securely fastened to the grounding screw. The grounding screw must be tightened to the proper torque to ensure a reliable connection. It is also important to ensure that the enclosure is clean and free of any paint, rust, or other contaminants that could interfere with the grounding connection. The National Electrical Code provides specific requirements for the installation of grounding and bonding systems. These requirements are designed to ensure the safety and reliability of electrical installations. Grounding and bonding are essential for minimizing the risk of electrical shock, fire, and equipment damage. Grounding refers to the connection of electrical equipment and circuits to the earth. This provides a low impedance path for fault current to return to the source, allowing the overcurrent protective device to operate quickly and clear the fault. Bonding refers to the connection of metal parts of an electrical system to create an electrically conductive path. This ensures that all metal parts are at the same electrical potential, minimizing the risk of electrical shock. The National Electrical Code requires that all electrical equipment and circuits be properly grounded and bonded. The specific requirements vary depending on the type of equipment, the voltage, and the location. It is important to consult the National Electrical Code and other applicable standards to ensure that all grounding and bonding requirements are met. The size of the grounding conductor is determined by the size of the ungrounded conductors in the circuit. Table 250.122 in the National Electrical Code provides the minimum size requirements for grounding conductors. The grounding conductor must be large enough to safely carry the fault current back to the source. The grounding electrode conductor connects the grounding electrode to the main grounding bus bar in the electrical service panel. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. Table 250.66 in the National Electrical Code provides the minimum size requirements for grounding electrode conductors. The grounding electrode conductor must be large enough to safely carry the fault current from the grounding electrode to the service panel. The grounding electrode is a conductive object that is buried in the earth and connected to the grounding system. The grounding electrode provides a low impedance path for fault current to dissipate into the earth. The National Electrical Code requires that all electrical services have a grounding electrode. The most common types of grounding electrodes are ground rods, metal water pipes, and concrete encased electrodes. Ground rods must be at least 8 feet long and must be driven into the earth until at least 8 feet of the rod is in contact with the soil. Metal water pipes can be used as grounding electrodes if they are in direct contact with the earth for at least 10 feet. Concrete encased electrodes, also known as UFO grounds, are made by encasing a bare copper conductor in concrete that is in direct contact with the earth. Bonding is the connection of metal parts of an electrical system to create an electrically conductive path. This ensures that all metal parts are at the same electrical potential, minimizing the risk of electrical shock. The National Electrical Code requires that all metal parts that are likely to become energized be bonded together. This includes metal enclosures, metal raceways, metal pipes, and metal equipment. Bonding is typically accomplished by using bonding jumpers, which are short lengths of conductor that connect the metal parts together. Bonding jumpers must be properly sized according to the size of the circuit conductors. The National Electrical Code also requires that all metal water pipes be bonded to the grounding system. This is to prevent the water pipes from becoming energized in the event of a fault. The bonding connection must be made as close as possible to the point where the water pipe enters the building. In addition to the requirements for grounding and bonding, the National Electrical Code also provides requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When an overcurrent occurs, the overcurrent protective device will trip, interrupting the flow of current and preventing damage to the electrical system. The size of the overcurrent protective device must be properly matched to the size of the circuit conductors. The National Electrical Code provides tables that specify the maximum size of overcurrent protective devices for different sizes of conductors. It is important to consult these tables to ensure that the overcurrent protective device is properly sized. The National Electrical Code also requires that all electrical circuits be protected by ground fault circuit interrupters, or GFCIs, in certain locations. GFCIs are designed to protect people from electrical shock. They work by monitoring the current flowing in the circuit and comparing it to the current returning to the source. If there is a difference of more than 5 milliamps, the GFCI will trip, interrupting the flow of current and preventing electrical shock. GFCIs are required in bathrooms, kitchens, garages, and outdoor locations. The National Electrical Code is a comprehensive set of standards for the safe installation of electrical systems. It is important to consult the National Electrical Code and other applicable standards to ensure that all electrical installations are safe and compliant. The grounding screw must be installed in a location that is readily accessible for inspection and maintenance. It should not be installed in a concealed location or in a location that is difficult to access. The grounding screw should be protected from physical damage. It should not be installed in a location where it is likely to be struck by equipment or other objects. The grounding screw should be installed in a dry location. It should not be installed in a location where it is exposed to moisture or water. The grounding screw should be installed in a location that is free from corrosive substances. It should not be installed in a location where it is exposed to chemicals or other corrosive materials. The grounding screw should be installed in accordance with the manufacturer's instructions. The manufacturer's instructions will provide specific information on the proper installation and use of the grounding screw. The grounding screw should be inspected regularly to ensure that it is in good condition and that it is properly connected. If the grounding screw is damaged or corroded, it should be replaced immediately. The grounding screw is an important component of the electrical system. It helps to protect people from electrical shock and to prevent damage to electrical equipment. It is important to install and maintain the grounding screw properly. The use of a grounding screw for direct attachment, as permitted by NEC 250.48, requires careful attention to detail and adherence to the code. Firstly, the enclosure itself must be suitable for accepting a grounding screw. The enclosure needs to have a designated point, often a pre-tapped hole, specifically designed for this purpose. Secondly, the grounding screw itself must be listed for the purpose of grounding. This ensures that the screw is made of the correct material and has the proper design to create a reliable electrical connection. Thirdly, the grounding conductor must be properly sized according to the requirements of NEC Table 250.122, based on the size of the overcurrent protection device protecting the circuit. Fourthly, when attaching the grounding conductor to the screw, ensure that the conductor is properly stripped and foamed to make good contact with the screw and the enclosure. Using a ring terminal is often recommended for a secure and reliable connection. Fifthly, tighten the grounding screw to the manufacturer's recommended torque specification. Over-tightening can damage the screw or the enclosure, while under-tightening can result in a loose connection. Sixthly, after the connection is made, inspect it carefully to ensure that the grounding conductor is securely attached and that there are no loose strands of wire. Seventhly, ensure the enclosure is properly bonded to the building grounding system. This may involve connecting a bonding jumper from the enclosure to a nearby grounded metal object, such as a metal water pipe or a structural steel member. Eighthly, always refer to the latest edition of the National Electrical Code and any applicable local codes for specific requirements and interpretations. Ninthly, only qualified and licensed electricians should perform electrical work, including grounding and bonding. This ensures that the work is done safely and in accordance with the code. Tenthly, proper grounding and bonding are essential for electrical safety. It protects people from electrical shock and helps to prevent electrical fires. It is important to take grounding and bonding seriously and to follow all applicable codes and standards. A grounding screw provides a direct connection to the enclosure for grounding conductors, which is crucial for electrical safety.